Okay, guys, from the last program that I wrote, you can see that it's very slow when you want to call the index. There's just a little bit more hard, like higher level, higher index. Uh, for example, if I would like to find Fibonacci of this term, uh, it's not the problem if you want to find Fibonacci of, for example, of 6 something. It quite very fast, right? And if you want to call 15, it's still fast. And 20, yes, still fast. And 30, yeah, 40. Now it a little bit slow, but if you want to find 45, it is much slower, right? Can you see? Okay. Uh, and if I want to call like 50, it is significantly slower than 40, right? So how can you write a program that makes it faster? So I cannot wait. I cannot stand this. So I will write a program to show you how. We call it like the dynamic programming to store the values, but maybe the result of Fibonacci is maybe it's greater than the integer number. So I will make it uh, an array of log. We call the store Fibo. Okay. Okay. So I declared here, and in the main program, I'll start save it. So stored Fibo is new long same number 50. Okay. Okay, I forgot static. Okay, because it the Fibonacci stored Fibo is in the static of main, so this variable must be static. So I save it here. So uh, if we can find the number, we will store it like this. We will store it here also. So stored Fibo of index is, I will calculate it here and return this one instead. Okay. So it is like if we already calculated it, so we will use this value instead of newly calculated it again. So if index still, this one is still the best case, but in another idea, if stored Fibo of index is not 0, because once you create this one, all of values are zeros, right? So and the Fibonacci is not 0, the values is not 0. So if it's not 0, what does it mean? It means that you already calculated, right, for this index. So it's quite simple that you can return the this one. But if not, you have to newly calculate it and store it in the stored Fibo and return this one, this value. So let's try. Can you remember that we find 50 and it's very slow, right? So now this time let's see the result. Oh, oh, sorry. Unresolved compilation problems. Cannot convert from long to int in 6 and 18. Okay. 18. Okay, it's not int anymore. I'll change it to long. Okay, you change it to long and then run it again. 6 and 17. Ah, array index out of bound. Because it's 50, right? But we have 50 of them, so maybe we can make it like 51. It should work now. Yes, it's fast, right? Very fast. Because you don't need to repeatedly compute it again and again. For the number, for the index that you already calculated, you just return the values from the array that you stored. If not, you have to find a new one, right? So now it will be very easy for you to run for 60, right? Fast, very fast, right? It's not same as the previous version that when you input the value like 50, you have to wait very long time. But this time we don't need to wait. Okay, we call this one like the dynamic style of dynamic programming. Okay, the one that's already stored will be recalled. Okay, so uh, that's all for this clip, and I'll show you in the next clip that how about if we want to run this recursion or in uh, the recursion with the string. How can we do it? Because in our assignment, you have to find a palindrome of the string to check whether a string is palindrome or not. You have to find actually the palindrome is the string that you can read from front to back and back to front. You'll get the same result, like Madame Adam, something like that. And you can see a lot of example of the palindrome string in the internet. Okay, uh, this is our assignment, but I'll show you how can we write the string in the recursion using the string. Okay, see you in the next clip.